Welcome to this DEHN Safety Products and Devices for Working on Electrical Installation webinar. My name is Pasi Rantanen. I'm working in Finelectric as Sales Team Manager. Here is our agenda for today. It's in the beginning this very short introduction of companies to arrange it and speakers, and then itself the DEHN presentation. And after the presentation, we will reserve time for questions and answers. So please do that after presentation. Then a couple of words about the arranging companies. There is two companies, Klinkmann and Finelectric, who is arranging this this event. Klinkmann is a supplier of industrial automation solutions, whereas Finelectric is mostly concerned about electric distribution, high voltage solutions, and also this DEHN products. Finelectric operating in Finland, whereas Klinkmann is operating in 8 countries and 11 locations in Eastern Europe mainly. Next presentation will be kept by German company DEHN, whose products Klinkmann and Finelectric has been delivering for several years. Thomas Matlock will be presenting the presentation. Here you can see also my information and email contact if you wish have something offers or whatever regarding these products. But I think it's time to continue and proceed to presentation. Matlock, presentation itself. So please.
Okay. So I will try to start my screen here. Okay, so I hope you can see it. Good. Yeah, thank you very much, ladies and gentlemen, for taking the time today to listen to this little introduction of safety equipment from DEHN. Thanks to our partner for having this opportunity to do this presentation here in Finland for you. You probably know DEHN already as a manufacturer for lightning and surge protection. We do this for a very long time. And nevertheless, besides those products, we have for decades already special dedicated products for safe working in electrical equipment as well. The background for that is that DEHN, which is today 111 years old, started actually as a electrical contracting company. And so we have the experience, and we still run today a branch for electrical installation here in Germany. So this is under the brand name DEHN Instatec, and we still have about 300 workers in that branch. So that means we have the experience with the applications in electrotechnical installations, and that's why we also offer here special products for that. The initial reason, by the way, was that the founder of the company, Mr. DEHN, he became an eyewitness of an accident of one of his workers in electrical installation, and the worker died during that. And so then it came up to his mind to think about products and instruments making the life easier for the workers and make it safer, of course. Good. So my name is Thomas Matloch. I'm, as you have seen, a technical expert here. I'm with the company for 30 years now, so I've seen a lot of development here in the company. I've been also in international sales for a while in several countries, have seen the installations in several of the countries, the what they have in common and what is different. So honestly, I'm not familiar with the situation in Finland, but this is up to you to adapt this information to your own situation in your country. Okay, good. So let's start in the first part here about the so-called safety rules, as it is listed here. And this is a list of safety rules typical for the work here in German installations. And this is also part of a standard, in this case, the VDE 0105 here in Germany. So it contains 5 rules, as you can see. So first of all, the worker should disconnect the electrical connections completely. He should secure that nobody reconnects it, and he should verify that the installation is really without voltage, and he should carry out earthing, a solid earthing and short circuiting of the equipment, and he should provide protection against the adjacent part which are still under voltage. So those are the 5 rules. Beside that, there are different methods in common as well. So some workers are also working under lifeline conditions, as you know. And this is a very special branch, not part of the today's presentation here. There we have a special situation that the installers are especially trained for that, and they are really aware of the danger of voltage because the voltage is present. And as we know from statistics, from several associations in electrotechnics, the number of accidents in this lifeline working is very, very low compared to the regular work. Okay, so let's go ahead. First of all, here we have the safety rule number 1. It says to disconnect everything completely, and therefore you can see here on the picture the worker with the special clothes on, protective clothes to this is not an isolating clothes, so it is just to make sure that when there is an arc fault, that his skin is protected against the heat and the flames which might come out of the equipment. And as you can see in his hand, he has an electric tool, an isolated tool to trigger the switch in this case. And as you can imagine, this is of course isolated, as you can see. And let's take a closer look at this. Here we have such as an example, such an instrument, as you can see here. Let's start from the right to the left. On the right, we have the handle where he can put his hands on the device. And there is also, as you can see, a hand guard as a visible barrier. So his hands should be always behind this hand guard, of course. And above this, we have a special insulating element. The length of this element depends on the nominal voltage of the equipment where this is used in. it provides a certain safety distance, and it provides as well the air distance to the live parts of the equipment, and to ensure a safe operation, of course, because this is like a life insurance for the worker, of course. And on the left part, you can see this red ring as a visible limit for contact with live parts. So the last part of the tool on the left-hand side is here called insertion depth. So that means there should be no live part below this red ring when you go into the equipment. And this piece, of course, depends on the construction of the equipment where it is used, of course. If you have short distances or longer distances. Okay, so later on we will speak about the special closes for the installer as well. Here we have a picture of some old instruments you might find still today in older installations. And those are elements which are not made after the latest standard. Here we have different sources of faults, as we can see. You can see on top of it, we have metallic parts on it. So there is always a danger that this metal part could bridge some elements within the switchgear cabinet and create arc faults. So this is not safe, of course. Sometimes you see those things where something is broken, or the hand guard does not exist, or some are without a label, so you have no idea for which voltage this can be used. Some words about the maintenance test I will explain later. One example is this brown tool, as you can see here. So it is made of so-called laminated paper. And it turned out over the time that this laminated paper is very hygroscopic. That means it attracts water, humidity, and then the isolation is not given anymore. So I have seen real tests with this in our high voltage laboratory, what we run here on our premises. And you can really see that there are flashovers over the surface of this material. So this can be very dangerous. Okay, good. Next one. Second safety rule, it explains here that, of course, a reconnection of the equipment must be reliably prevented, to make sure that the worker is really working under no presence of voltage anymore. And therefore, there are tools available to make it sure, warning signs like that what you can see there. And this is also a life insurance for the worker in that equipment. That reminds me of an documented accident which happened in Germany some years ago. There was a worker in an industrial equipment in a 5-story building, and all the 5 levels, they had exactly the same electrical installation in it, so the same distribution boards and the same switchgear cabinets. And after the lunch break, he returned back to work, and he confused the levels of the building. So he thought his switchgear cabinet is dead, no voltage is present, and he touched it and he died during this accident. So something like this can be prevented by using instruments like this, showing exactly that this is there's no voltage, and this is really visible, and you can also prevent that somebody else is switching it on again. Good. Safety rule number 3 is about verify that the installation is dead. So therefore, the worker here in this picture shows an instrument, which is a voltage tester, a mobile voltage tester. And this is not a measuring instrument, by the way. You don't measure the voltage in this case. He only gets the information if voltage is present or it is switched off. So this is important for him, just to have this information, not the exact value of a certain voltage. So this is shown here. And as an example, I can show you this one here. We have such a typical voltage tester here. And starting again, this time from the left to the right, we have a handle. And you see this little yellow piece on it. So that is due to the fact that it is possible to put an extension in, depending on the size of your switchgear cabinet where you want to use this device. And then again, we have the hand guard, where the hand always should be behind that to have the sufficient isolating distance to the lifeline parts, probable live parts. Yeah, here you check that the voltage is really switched off. And then, of course, we have between the handle and this red ring, again, we have the indicator showing if voltage is present or not. So on top of it, above the red ring, we have this test prod with a contact electrode, and this allows to reach remote installation parts, of course. And there are different prods available depending on the switchgear cabinet you are testing. The simple rule of thumb is when you have outdoor applications, you have typically longer distances, and therefore the prop is also longer in this case. And for a lot of indoor applications, there is a shorter prod typically in use. And with the red ring, the same as I said before, it is a visible limit for contact with live parts, of course. Yeah, some words about this, the functionality of this voltage tester. Here we have an example of a voltage detector up to 36 kilovolts. And as you can see in the picture, so we have opened the device here, and it shows the inner installation of this of the device, and there is a chain of resistors inside. And as we know, every device can fail, and therefore there is a self-test mechanism included to make sure that this device really works. So when you put it in function, there is a functional time for 4 minutes, and there is a self-test included showing the installer that the device works properly. And of course, this is in the highest interest of the installer itself, that he has a really functioning device. Good. So the next one here, the indication in this case is both visual and audible. That means even in cases where you have strong sunlight in front of you, we have super bright LEDs inside, and that shows you exactly the functioning of the device, even if there is a lot of light around the place of installation. And the second signal here is audible. That means there is a very loud beeper, which shows you the functioning even under very rough conditions and loud conditions in industrial environment. Yeah, so this indicator panel is transparent, as you can see here, and it shows us in different directions as well. Good. Safety rule number 4 is about earthing and short circuiting. Therefore, typical devices like that one, what you can see here in the pictures, are defined. Here we have the one end of this instrument with the one pole is for the earth connection, of course, and the other 3 poles are for the lines in this case, when we speak about 3-phase installations. Good, and of course, this can only be installed when the installation is dead. That means one rule before we have already tested that there is no voltage present anymore. So then you can safely install this instrument. And the typical way how to do it is, of course, to put first the earthing connection, and after that you connect the phase connections. Good. This is shown here as well in this picture. So step 1, as you can see on top, explains the earth connection is done first, and therefore typical parts in the switchgear cabinet are available where you can fix it, and there is a variety of different clamps which can be used here for this earthing and short circuiting device. And the second step, as you can see below that, is the connection with the phases. And there we have also, in this example, we have this ball point which is fixed on the equipment, on these big rails, on these bus bars, to connect this material. Of course, this material should be visible from the work location, or should attached as close as possible to the work connection. So this gives, of course, the installer a certain even feeling of safety, that he sees, okay, all this equipment is solidly grounded and short-circuited, and I can work on it. Yeah, different clamps, as I said, are available for that, as we can see on the right-hand side. And depending on the size of it, there are also tools available to mount it in the installation where this is needed. By the way, on our international homepage, which is indicated here, www.DEHN-international.com. So we have the opportunity of filtering the different options of those parts, and this is a customized part, so it is produced order by order, and there we have an instrument to make the right choice for the application. You have to have the cross-section areas, to have the right clamp which is needed, and so on. Okay, so this is, of course, online configuration, and it can be done easily. Good. So let's come back to our safety rules. Rule number 5 is about the insulation of adjacent parts of the installation which still have voltage, and to make sure that unintentionally parts of that can be touched, there should be an extra insulation, as we can see here. In this case, we have a special switchgear cabinet where this opportunity for such a shutter is relatively high. So that's why there is a tool for this as well, to fit this shutter in the installation. Usually we have different shapes of these shutters, and they are also manufactured by order, depending on the size which is needed. It's a customized part. And yeah, you can see here in the pictures that there are different shapes available for that, depending on the construction of the installation. In this A1 picture you can see, so this is in a reachable height of the installation, so the installer can take it in his hands and fit it in. The type A3 on the right hand side is what we have already seen, so this is much higher, so therefore the installer needs an instrument, a tool to put it in. And this type A2 has own handles on it. It is another kind of material, and this can be fixed like that. And example number 4 shows there are different sections cut out of the shutter because it needs to fit exactly in the switchgear cabinet, and this can be done only when you know the exact dimensions of the application. Okay, good. Yeah, so that was about the 5 safety rules. I come to another chapter here. Let's talk about this so-called arc fault protection. And honestly, I don't like this picture very much. So that was done by our marketing ladies. And for me as a technician, I honestly don't like it, because it looks like James Bond is leaving the scene, and behind him you have a lot of explosion and a lot of flames. So this is not the intention of safe working in equipment, of course. Arc fault protection, but an arc fault is a very serious matter, as you probably know. So when we look at this actual picture here of a switchgear cabinet nearly exploding due to an arc fault, so we should talk about the parameters of such an arc fault. Yeah, definition: what is an arc fault? It's an electric gas discharge between 2 electrodes. Electrodes can be parts of the equipment. This can be conductive parts, of course, between parts having voltage and earthed parts, or between 2 phases as well. And yeah, when there is an arc fault, then there is a discharge via a plasma practically, and this plasma can reach temperatures up to 20,000 centigrade, which is a big threat for installers working in such an installation. So from the technical point of view, this is mentioned here as well. An arc fault is not a bolted short circuit, because it has a certain impedance. Yeah, this conductive gas has a certain impedance and is influencing backwards also the actual current flow in this case. Good. So let's speak about the effects of an arc fault. So what can happen when a person is in the vicinity of this area? Of course, you can have serious injuries or even deaths of people as a result of burns or the result of the inhalation of toxic gases. When there happens such an arc fault, some metals are vaporized, other parts will be vaporized, and as typical behavior of a human being, when such a shock appears, you typically inhale from this shock, and this is relatively dangerous, of course. So when you inhale those toxic gases, this can kill you. And then we have fire and flames here, of course. It can lead to a complete destruction of the switchgear assembly, of course, and the fire can spread to other parts of the installation as well, and can burn a lot. It can lead to destruction of the joining areas by the pressure wave as well, because such an gas develops also a high pressure in this field. And not to mention, of course, the downtime in production where this application is located, and not to mention the financial loss which result in such an event. Why do typical arc faults occur? So here we have three reasons. Three main reasons, of course, from installation errors, from operational faults, and from animals, of course. So installation faults can happen during maintenance and inspection, when you work on live parts, or you replace some elements within the switchgear cabinets, or you replace fuses or something like this. And very often it happens that tools will be forgotten in the installation, and when it comes to vibration, then such a tool can fall on live parts, bridge them, and then you can have an arc fault. Operational faults are typically insulation breaks, poor contacts, condensation, surges even, so voltage peaks from the grid, or insufficient dimensioning. From the animals, rodent bites, of course, what we have in Europe. Actually, I've seen pictures, interesting pictures from my Indian colleagues. They showed me a big snake within such an installation, and this is, of course, bridging conductive parts, and this can lead also to faults. Some years ago, I visited some installations in the States, by the way, and this gentleman told me that the main reason for arc faults are raccoons, by the way. And he asked me, "Do you have raccoons as well in Europe?" At this time, I said no. Today, I think I should give another answer, because several countries, they have problems with raccoons as well. Good. What are the effects after such an arcing fault? Therefore, we have this this comparison between, let's say, good material on the left-hand side and insufficient material on the right-hand side. Here we have special gloves tested for this purpose. They can withstand certain energies of an arc fault. And you can see also this face shield in this case, protecting the face and the upper part of the body of the installer. And on the right hand side, you see what happens when you use insufficient material, which can burn, get holes, and will lead to injuries for the operating personnel. From our association from electrotechnical industry, we have some statistic figures here, as you can see, and it shows from the statistics standpoint, which part of the human body will be injured during such an accident. And yeah, as we can see, most of them on the hands, and here it is a little bit more on the right hand, because most of the people are working with a right hand, and of course in the face and head of this person. Okay, good. So that means to protect the worker from this effects of an fault arc, he should wear a personal protective clothes, of course. And yeah, the employer of the worker has to make sure that the clothes are tested after certain standards, of course, and they have to make sure that the worker is also using it. That this is not only beside the installation, but he has to make sure that he's really using it. Good. So that's why some words about the so-called DEHN Care arc fit clothes, what we offer here in our catalog. You can find it as well on our homepage. Yeah, this is the typical advantages are mentioned here. It fits good, it's comfortable, and it protects perfectly. So this is written down here, and even the labels on the protective clothes show which tests have been done for this material. Yeah, we have very resistant protective clothing, and the standards after that the material is tested are mentioned here, as you can see. We have used different standards. Sometimes there are little differences in the test procedure from standard to standard, and I think the most common testing standards are mentioned here. So there's this protection against heat and flame, and even against electrostatic properties is here given. And you can use this clothing as well during welding and similar processes where heat is developed. Yeah, and of course we have a high visibility, and don't be surprised, there is also a standard available for that, to give categories for this visibility. And additionally, here we have the protection against liquid chemicals defined in a standard as well. Yeah, we speak here about a single layer material, which is water repellent, washable as well. So this is important. This is not for one-time use. And jacket and trousers can be ordered separately. You see the frame here for the different sizes we offer these clothes. between 46 and 62. And this is certified after the here mentioned regulation. Good. Yeah, here we have a summary of these clauses. Of course, it is has a very high varying comfort. It even looks fashionable, as some of our marketing ladies say. Looks sporty and light, of course. And here we have two different variants of it. So on the left-hand side in the picture, we have the indoor clothing with some parameters mentioned here as well. And on the right-hand side, we have the outdoor version of it, also with the parameters. Yeah, smooth material, striking colors, reflective elements on it, which is sometimes needed for outdoor applications. Yeah, and of course we have elastic waistband, multi-purpose pockets to carry whatever the installer needs in the application. Then available from DEHN here as well, there's an online configuration of this personal protection material available as well. As I told you, indoor collection and outdoor collection. You can choose here after material and colors and color combinations of the elements. The customer logo as well can be printed on it, and it can be personalized with the name of the owner or company or the name of the worker itself. Good. One word about the face shield we are offering here, what I can tell here about this is different from a regular material what you have for skiing. When you use glasses for skiing, you know there are always scratches and little breaks inside. So this is not so here for this material, and the reason is this is a 3D manufacturing process. That means the shield is cast directly into the final form. That means the material will not bend to this red-shaped frame here. It is casted like that. Yeah. Good. So that's why we have a higher lifetime here, of course, for this type of material. And the crack formation and material fatigue are considerably reduced, as it is mentioned here. Yeah, this protective effect retained for years, even when scratches from outside, mechanical scratches appear. And that means, of course, you can save costs for replacement of the material. Yeah, we have to keep the balance here, of course, between both indications here. On the left-hand side, we need a clear vision, and on the right-hand side, we have to balance this with a certain blocking of energy. Of course, when the worker is wearing that, he needs a perfect all-round view. And the color recognition is also very important for him, especially when it comes to cables that is here described. So he has to see actually which cable is red and which cable is green, to see it through the face shield as well. Yeah, an anti-mist coating is already on the material, and this is permanent. That means there is no subsequent treatment with an anti-fog chemical needed. So this is a feature what the material has from the beginning. Okay, so it protects against second degree of burns, of course, to the human skin. And one additional information, I think this is also important in the event of an arc fault, the active protection triggers a so-called controlled carbonization. And that darkens the shield. So when the heat hits this shield, you have a controlled carbonization. That means it darkens, and you have a reliable protection of the face skin of the worker in this case. Good. Yeah, some words about so-called active arc fault protection under the brand name here of DEHN Short. I would like to spend some words on this as well. We have a complete program as an active protection, and as you can see here on the picture, on the left-hand side, it's a control system, consists of a controller collecting the signals from different sensors. There we have a sensor for light, and this is combined with a sensor for current in the switchgear cabinet. So the different topics here for the left-hand side, there is no integration test needed, and we have an arc fault quenching time of 40 to 50 milliseconds, depending on the breaker, because the signal from this controller is connected to the regular breaker, which is within the installation. And when the controller gets the information, okay, there is a strong light in connection with a big current flowing, that means this is an arc fault, and then the breaker is triggered to switch this off. Yeah, so that's why here on the left-hand side, downtime of the switchgear assembly after such an event, several days, and the device, due to the quenching time, delivers personal protection, can be used in low voltage and medium voltage applications. Compared to this, we have on the right-hand side an instrument, similar controllers in combination with sensors for light, different shapes of light sensors, punctual sensors, and this fiber optic sensor to be connected with a controller. And in this case, on the right-hand side, we have a connection to an active device. So that's why we call it arc fault mitigation system. So this is drastically reducing the quenching time up to 3 to 4 milliseconds with this short circuiting element, what you can see here. In this case, the controller is not triggering the breaker in the equipment. It is triggering an active element, creating a bolted short circuit in the equipment. And after such an event, you have downtime of such an assembly of a few hours. So in this case, you have to exchange this short circuiting instrument, and then you can run the equipment again. And in this case, we have personal and system protection. This is available for low voltage applications. Yeah, some overview here about the elements which I used. As I told you, regarding the functioning, on the left-hand side, we have the different sensors, light sensors on top, and then the current sensor, which is needed as well. And then when the controller sees both signals, light and current, then it gives out a certain signal, and then we have this quenching element. In this case, we have a short-circuiting element on the right-hand side, which is creating a short circuit. Yeah, the functioning behind is a mechanical element, and inside you have a loaded spring, and the spring has to move some mechanical, solid metallical parts to create a short circuit, and the short circuit in this case will release the circuit breaker for the whole installation, and then voltage and current will be switched off. Good. So this is about the functioning, and of course here the installation follows the logic of the instruments what we have seen here. Number one, this is the short circuiting instrument, and you can find it there in the application on top of this switchgear cabinet. So it has solid connection to the bus bars, and there is one installed between line 1 to line 2, and a second one between line 2 and line 3, indicated with this one. Yeah, the light sensors in this case are located on different positions, because such a arc fault can happen in different positions. And to verify the signal, here we have two of those sensors. One is mounted here, the other one is mounted over there, and the control unit is here within the door of this cabinet. Yeah, so when this is a larger installation for, let's say, big hospitals or something like this, then they usually put it in an extra part of a cabinet. Okay, good. So that was about yeah, the 5 safety rules about personal protection for workers in electrical equipment, and about active short-circuiting devices for earth fault protection. Good. So that was it.
Thanks, Thomas. And then we have a couple of questions. Can you see that question, what is there in the system, or should I read it to you? I will read at least one. One is, I think in Finland, the short circuit currents has grown in electric grids of German and European area last 5 to 10 years. How has situation shown in the business of DEHN?
Yeah, we have seen similar developments. So that means, depending on the part of grid we are talking about, so when we take, let's say, low voltage applications, in such a case, you have to find the balance between higher prospective short circuit currents and the handling of these earthing and short circuiting devices. You can imagine when the current gets higher, you need a bigger instrument for this. And this is somehow limited because the worker has to install it somehow, and the material can get very heavy when the cross sections are very big. So that's why a lot of them use an parallel installation of those short-circuiting elements. They put 2 of them, depending on the short-circuit current, what they expect, and they should be installed exactly next to each other, yeah, to deliver this parallel, bigger parallel connection, and to make sure that the element can handle such a short-circuit currents. Another aspect is maybe what we have seen in high voltage lines, for instance. We have seen that the wires in high voltage installations get larger and larger, thicker ones. So this is sometimes also a problem for clamps, rope clamps, what you use in installation. So the clamp must be big enough to handle bigger cross sections of such a rope. This is what we see actually for our business as well.
Okay, then there is another question. Is there a demand or a rule in Germany to use protective gloves, for example, when electrical expert is verifying that the installation is dead?
When it is dead, and you have using what kind of gloves?
I don't know, protective gloves.
Yeah, so usually this is a protective clothes, of course. This is a basic, of course, for installers, because you never know what happens. So let me give you one example. Speaking about renewables like photovoltaics or something like this, you have often the case that you get the current in an installation the other way around. Usually the installation is a unipolar installation. So it was built for having power stations, bring the electric energy to high voltage lines, to have substations, bring it to the medium voltage level. And at the end of this line, you have low voltage transformers bringing the electricity to houses and other buildings. So it's a one way. And today we have the situation that there are PV installations, for instance, and you have the electricity flow backwards. So it can happen that from the other end you get a current, and you have to make sure, working on such an equipment, that you are safe even in such a case when the electricity comes from the other side.
Okay, thanks, Thomas, for your presentation. And we will deliver all of you the materials, and if you have any questions, please contact to Finelectric or Klinkmann regarding all the areas, 3 areas: surge protection, outside lightning protection, or safety materials. Everything, please send to us, and we will find the solutions for you. Thanks and bye.
Very good. Thank you. Bye.